All right, chapter 8 is about graphing the periodic functions. So when you're graphing sine and cosine, it's gonna end up looking like this over and over again. Periodic means it repeats the same pattern over and over. So the period of sine goes up and then down. So one period is this shape, and it repeats that shape over and over again. This chart shows the values of sine at different radians of x. So it's periodic because it repeats. Positive values represent quadrants 1 and 2. The negative values down here represent quadrants 3 and 4. It's symmetric about the origin, meaning if we went the other way, it would be a mirror. Symmetric would be rotational, making it an odd function, if you remember way back to that part. But in general, that is the sine function. And this part right here with the quadrants is referring to the unit circle that we talked about in 7. But if we were to graph the function of sine, so if we took the sine of 0 degrees, the sine of 45 degrees, the sine of 90 degrees, that's what these are here, we would get these values, and that's what the graph would look like, and it would repeat every 2 pi radians, and it would look like that over and over again. So if I showed you this really quickly on a graph, radians, yeah, it would look like that over and over again. And if I zoomed out, it would just keep doing that same shape over and over again forever. Cosine is the same thing. It's periodic because it repeats it forever. The positive values represent quadrants 1 and 4 on the unit circle. So 1 and 4, and then quadrants 2 and 3. In the long term, cosine and sine look very similar, just shifted. So if I zoom in a little bit, they're the same graph, just shifted vertically, left and right. But when you only look at one period, the difference is sine goes from the middle to the middle. So I say like midline to midline. And we'll talk a little bit about what that means in the middle. And then cosine goes from max to max. So that's visually how you can kind of tell the difference in the periods when you're trying to kind of graph them or write the equations. So although they are the same graph, and you could write a sine or cosine equation for either, you would just have a different period, which we'll explain shortly. The biggest difference is when you're looking at one period, sine goes from the middle of the graph. You start at the middle, go up, then down. And cosine, you start at the max and end at the max for each period. Again, we're going to get into those details in just a second. The domain is always all real numbers. And the range of the parent function is -1 to 1. So the bottom of these always bottoms out at -1, and the top bottoms out at 1 for the parent function. And then it repeats every 360 degrees or 2 pi, which, if you remember the unit circle, is one circle. So you're going to notice that period will repeat every circle, which makes sense with our coterminal angles. So sine starts at the origin, cosine starts at the maximum. These are called sinusoidal functions. That's just a fancy name for the shape. You don't really need to know that off the top of your head, but anytime this word comes up, it's just talking about that shape of a cosine or sine function. So that's just the general overview. These are those values we talked about in chapter 7 with the sine or cosine of the special angles. It's just kind of show you how those graphs come, how we get the points of the graphs. It's just by plugging in sine of x and cosine x of those special angles. So this first page is just kind of an introduction. There's some more words that we're going to talk about shortly. Period is how often it repeats. Amplitude is a height. Those are the things we're going to talk about in this section. So here we go. Period is how often the curve repeats itself. So the general form of our equation is this. A is some number in front of the sine or cosine. B is some number in front of the x. C and D are numbers that are added or subtracted. So transformations that we talked about earlier in this class help us in trig, which is sine, cosine, tangent. They just have special names in trigonometry because each thing does something different. So period, we're going to use the B here, or something to do with the B. That's still not the highlighter. In order to solve this. The parent function, so when it's just y equals sine x or y equals cosine x with nothing in front, the period is 2 pi. The period is the same as our horizontal stretch or squish. So if there's anything in front of x, you divide by 2 pi to get the period. That's b, whatever's in front of the x. So if we look at this example 1, there's a pi over 6 in front of pi. So to find the period, we take 2 pi, which is the period of the parent function. So that's the parent period. Divided by whatever that number is. So pi over 6. So that's divided by what's ever in front of x. And then we do that math out. So when we divide fractions, we keep the first one, change the division to multiplication, and then flip the second one. So pi over 6 becomes 6 over pi. And then we multiply. So 2 pi times 6 becomes 12 pi. 1 times pi becomes pi. And then the pi's cancel, and we get 12. So the period of this function is 12, which means on a number line, that shape would start at 0 and end at 12, and it would repeat every 12 units on the number line. If you look at this one, x over 3 is the same as saying 1/3 times x. So now that you know that, pause the video and find the period of this function. So we're going to do 2 pi divided by 1/3, which is the same as saying 2 pi times 3 over 1. So 2 pi times 3 is 6 pi, which means this cosine shape, max to max, would repeat on a number line every 6 pi. So if that's 0, this would be 6 pi. So that's what the period is and how to find it. You take 2 pi, divide by the number in front of x. Amplitude is the height from the middle. So it's kind of like half the height. Amplitude is going to be that A, the number in front of sine or cosine. So that's our vertical stretch. The amplitude of the parent function is 1, because on this graph we went up 1. We always use absolute value for our amplitude, so we ignore negative signs for this part. So on this graph, the number in front of sine is -4. So the absolute value of -4 is 4. So the amplitude would be 4. Which means if I were graphing this, my sine graph would go like that. So from this middle point, the height of this would be 4. Which means I would go up 4 and I would go down 4 when I'm graphing. The negative tells us we would flip it. So this graph would actually go down first, but we'll talk about that in a little bit. When we're talking about amplitude, we only really worry about how high, not the direction. So take a second and tell me what the height of this one or the amplitude of this one would be. Right. It's going to be the absolute value of whatever's in front. So the amplitude of this is 1/2. Good. So phase in terms of trig is just going to be how it's that shift, the horizontal displacement or shift. So the phase shift is going to be based on that C in here. So minus C. So that's our horizontal shift. Positive means left, negative means right, because when we're inside, we do that opposite. Now, if there's a B in front of the X and they're both in parentheses, we need to divide by that B. So for this one, there's nothing in front of the X, so my shift is just this. So positive means we're going to go left, pi over 6. If there was a number in front of the X, like let's say it was 2x plus pi over 6, we would have to divide out that period first, then do the pi over 6 because it's in the parentheses. So get rid of the period first if needed. And I'll show you some examples of that later. But if it's just X, you don't have to worry about that. So take a second and figure out the period of the U-try. The phase shift, sorry. So this one is negative, so we're going right. And then pi over 2. That just means when you're plotting that first point, instead of starting on the y-axis, you're going to start either left or right that far from that point. And then the direction is just your right or left. And then the final part we're going to talk about is the vertical shift. So that's exactly the same terminology as before with your up and down, your adding or subtracting. So midline is another word for the center. So if you remember, if our graph is looking like this is our midline, that line that cuts right down the middle before you're up and down. D, that vertical shift, is how high up or down that middle shifts. So where we start the sign from. And then positive is your direction, just like before. So all of these transformations are the same transformations we talked about with other functions. We just give them different names in trigonometry for whatever reason. So if we look at this equation, at the end, we have a minus 3. So that just means we're going to shift our midline down 3. So if you do the U-try, what would you do at the end of this function? You would shift up 3. So if we look at these and we put them all together, there's 4 things we look for. We look for the period. We look for the amplitude. We look for the phase shift. And we look for the vertical shift or the midline. It could be asked either way. So period is 2 pi divided by whatever's in front of the X. So 2 pi divided by 2 is pi. Amplitude, absolute value of whatever's in front of the sign. So absolute value is 3. Phase shift is anything added or subtracted in here. So this one has nothing added or subtracted inside the parentheses. And vertical shift is whatever's added or subtracted at the end. So we would go up 1, which the equation of the midline is a horizontal line. So that would just be y equals 1. It's another question it might ask is what is the equation of the midline? So the shift would be up 1. The equation of the midline would be y equals 1. So pause the video for a second and see if you can find those 4 things for this one. All right. So the first thing I want to do is divide out the 1/3 here, because 1/3 is what would be in front of the x. So if I did that, x divided by 1/3 is x, and pi over 3 divided by 1/3 is pi. So essentially I'm taking that 1/3 out, and then I could just, it's like saying cosine of this. So with that, I would do for my period, I would do 2 pi divided by 1/3, which is 2 pi times 3. So my period is 6 pi. Amplitude would be 1/2. Phase shift, I would use this after I divide it out. So I would go right pi. And then my vertical shift is down 2. So my midline would be y equals -2. What I did for that, so I had x over 3 minus pi over 3. And I said, hey, those both have a 3 on the bottom. So essentially, I said x over 3 divided by 1/3, which is x over 3 times 3, which gives me 3x, because those would cancel each other. Or sorry, gives me x, because those would cancel. And then I did the same thing. Pi over 3 times 3 over 1 gives me pi. That's where I got the x here and the pi here. X and pi. And then I just put 1/3 here, because that's what I pulled out. I divided by 1/3. That's why I put that in front. And I was left with x and pi inside, in case you were wondering what I did. All right. So that's how I find the pieces from the equation. Now we're going to use the graph to find the equation. So first, decide if we're going to do sine or cosine. And usually what I do for that is I figure out what's on the y-axis. Technically, you could do either. Like, either of these could be sine or cosine. But if you do what's on the y-axis, there's no phase shift. So y-axis as your starting point means no phase shift. So this one starts at a minimum. Sometimes it tells you cosine, right? But if it starts at a min or a max, that's cosine. If it starts at the midline, that's sine. That's really how you determine what you're starting with. So this one says cosine because we're starting at a minimum. So we know this one's going to be a cosine function. So now we're going to find all the things, and then we'll write the equation underneath. So cosine. So all of the things are period, amplitude, phase shift, vertical shift. So our period is how often it repeats. So for cosine, we do minimum to minimum or maximum to maximum. So minimum is here, the next minimum is here, and that's at 2 pi, which is the normal period. So since that's the normal period, we know we just put a regular x. There's no change. So after our cosine, we put x. Amplitude is the height from the midline. So we're going to draw the middle. We're going to find the middle, which is right here. And we're going to see how far we go up. So from that green line, which is 0.5, up to the top, that's a half. So our amplitude is 1/2. So we stick that in front. Our phase shift, because we started at the origin, is none. So we can just close the parentheses. And then our midline went through 0.5, so positive 0.5. So at the end, we write positive 0.5. That's our equation. I'm going to do another one. I'm going to do 3 and then have you do 1. So this one, we're going to start right here on the y-axis, which puts us in the middle of the function. So that tells us sine because it's in the middle. Like that yellow dot is in the middle instead of the max or min. That tells us sine. So then we find our period. So from that middle, we have to go up, all the way down, and then up again. So by the time we get there, that's 2 pi. So that's our normal period. So that's just a regular x. Amplitude. That's the height from the midline. So we're going to draw the middle and see how far up we go. So we go from 2 to 3. So that amplitude is 1, which means we put 1 in front, or we don't have to put anything if it's 1. Phase shift. We started at the y-axis. So none. So there's no shift. And then our vertical shift, our midline is at 2. So at the end, we're going to put plus 2. That's our equation. So we're just working backwards to find those things and then plug them into the equation. So before I set you free, I'm going to do one with a phase shift. So let's look at this one. We're not at the middle or on the edge or at the max, so that's not helpful. So we're going to go to the closest thing. So that's a max that's at a data point, right? Like the middle is right here. It's not really at 1 or 3, so that's not helpful. So the max is a helpful point. So we're going to do a cosine equation. So now let's do our period. So for cosine, we go from max to max, which means we go from 1 to 7. So our period is 6. To get the period from the equation, we did 2 pi divided by the number in front. So we have to do this in front of the x. So we have to do the same thing to go back. So we're going to do 2 pi divided by 6. And then 2 over 6 reduces to 1 over 3. So we're going to do pi over 3 right here in front of the x. Pi over 3 in front of x. Pi over 3x. So you find your period, and then just like when we were taking out of the equation, we do 2 pi divided by that to figure out what to put in the equation. Then we do our amplitude. So we find the middle. So that's 1. That's -5. So middle is 3. 1, 2, 3. So there's our middle. So our amplitude is 3. So we stick a 3 in front. Because cosine goes max to max, it's positive. If that had been a minimum, we just would have put a negative in front because we went min to min instead. Now we're going to do our phase shift. So instead of starting at 0, we went right 1. So instead of right, we put -1. And then I'm just going to stick this in parentheses so I don't have to deal. So you can either leave it like that with a double parentheses, or you can distribute that through. That's up to you how you leave it. And then we need our vertical shift, where we set our midline is at -2. So at the end, we put -2. So that's our cosine, because I chose to do that one with a cosine. Now let's say I chose to do sine instead. Okay, so that's cosine. Oops. I'm going to do the same thing, but now I'm going to do it like a sine graph, because you can always do either. All right. So let's say I said I'd rather go this way and do sine, because for whatever reason I like sine better. Some of these things are going to be the same, right? So my period should be the same. So if I do sine, I do midline, up, down to midline. My period should still be the same. Up, down, that should still be 6, which it is. So I would still do 2 pi divided by 6, which is pi over 3. My amplitude is still going to be 3. This time I shifted left 1, so I'm going to put +1 in there. That's the difference. But my midline is still -2. So if we look at the equations, the only difference is that vertical shift, horizontal shift. This is the only difference between the two equations. The period doesn't change, the amplitude doesn't change, the vertical shift doesn't change. So that's why it doesn't matter which one you pick. All that's going to change is your horizontal or your phase shift. So pause the video for a second and do the U-try. Do whichever you want. Do the sine or the cosine, it doesn't matter. I'm going to do both and see how you did. All right. Okay. If you did sine, you're going to pay attention to the top one. If you did cosine, you're going to pay attention to the bottom one. If you want to see both, you can pay attention to both. So, period. And this is the same for both of them. So for sine, your period went from 1 to 11, which would be 10. For cosine, your period went from -1 to 9, so it's still 10. So you would do 2 pi divided by 10, which is pi over 5. 2 pi divided by 10 is pi over 5. So for both of them, your period's pi over 5. Then we do amplitude. So we draw the middle, which is at 4. So from 4 up, our amplitude is 4. So we're going to stick a 4 in front. Sine goes up, then down, so it's positive. Cosine, we go from minimum to minimum, so our cosine is negative because we go from min to min. Then our phase shift. So for sine, we started at positive 1, so we went right 1. So in parentheses, I would do x minus 1. Cosine, we went left 1. So I would do x minus 1. If you had gone to this point up here for the cosine, because you wanted to do, you would have a positive 4 and x minus, or this should be plus 1, sorry, x minus 3 in here. So if you had chosen this blue point, that would be a positive 4, and in your parentheses would be x minus 3. So there's always multiple answers on these. And then your vertical shift is your midline. So your midline for both of them is y equals 4. So at the end you have plus 4. So there are two possible equations. All right. Now we're going to sketch a graph. So from the equation, you find all of the things. If you're doing it by hand, then you're just going to plot some points. So for cosine, for sine, you're going to plot those middles. So you're going to plot the middle, the beginning and the end, because you start at the midline and then the middle. Then you do your max and your min, and you get your whole face. Cosine, you do your max, your min, because your min's in the middle. And then you do your midlines, and you get your phase. So sine, your starting and ending points, and then the middle, then your max and min. Cosine, maxes, minimum, midlines. You can also put them in the graphing calculator and send me a picture. You can go to Desmos, send me a picture. On the website, you pick. So at the bottom of the graph, there's two choices. They both look like this. Hold on, let me draw it right. It's like, okay. There's one that has red dots here and one that has red dots here. The red dot that has the bottom and the top is cosine, because that's your max and min. And the one that has the dot in the middle is sine. Dot in middle. Max and min. So this is on the website. If you're graphing a sine function, you choose this one. You choose sine. And then what you're going to do is you place the midline. Then you place the max. And it will draw the whole graph for you. So you would put this point, and you would put this point, and it will stretch out the rest of the graph based on those 2 points. For cosine, you're going to place the max. Then you place the min. And it will plot the rest of the graph for you. So you put this dot and this dot, and it will graph the rest for you. So on the website, you just need those 2 dots. So you have to choose the right picture at the bottom and then put the right dots. There's also a clear all button. So that's how the MyOpenMath works. The only ones you'll have to graph are sine and cosine. Everything else, they'll give you the graph and you'll choose things. So pick the right button. Sine has the middle, cosine has the minimum. graph the two dots, and it draws the rest of the graph. So you still have to find these things so that you know how to put those two dots, but that's how you do it. So let's go through and do them. So, period, amplitude, phase shift, vertical shift. So period, pi over 2x. So we're going to do 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which would give us 4, and the pi's would cancel. Amplitude is 2. There is no phase shift because there's nothing in the parentheses. And there's no vertical shift because there's nothing up and down. So it's a sine graph, so I start on the origin. My period is 4, so that means I would end at 4. So my middle is at 2. If my amplitude is 2, in between those first two yellow dots, my max is 2. In between the second two yellow dots, my minimum is 2. That would be one period of the graph. These would be the dots I'd have to put on the computer. I'd put this dot first, then I'd put this dot, it would graph the rest. So you still have to be able to find those things in order to plot those pink points. Yep, okay. So I'm going to do another one with you, because sometimes we're going to be in radians. That's what these are on the graph. It all depends on what you get. So let's look. Period, amplitude, phase shift, vertical shift. So period is 2 pi divided by what's in front of the x. So 2 pi divided by 2 is pi. Amplitude is what's in front. So our amplitude is 0.8, but we need to pay attention that it's negative. So we're going to go down first. And I think I might have missed that up here. So notice, because I just did, that this up here was negative, which means my graph should have done the opposite. I should have gone down first and then up. So my points should have been these two. So it should have not been up. It should have been down. Missed that before. All right, back to this one. Phase shift. There's nothing added or subtracted in the parentheses. Vertical shift. Nothing added or subtracted at the end. And we're doing cosine. So usually it's max to max, but because it's negative, it's min to min. So our amplitude is 0.8. So our minimum, if I say this is -1, our minimum's like 0.8. And at pi, I'm going to do -0.8 again. And then my maximum would be +0.8. And halfway between those points is when I would cross the midline. So that would be one period of cosine. I could repeat it again if I wanted to. There would be another period. The points I would graph would be the min and the max, like the first and the second. And then the computer would graph them. If I did it on my calculator, I would click the y = menu, and then I would type those two equations in. So -2 sine, and then in parentheses, pi x over 2. And then for this one, -0.8 cosine 2x. On the calculator, you want to make sure you're in radian mode. So in the mode button, radians. And one thing I do like to do is I try to zoom to the trig. So zoom 7 for trig. just to make sure it's zoomed into like these pi values instead. So the blue in this case is that top one. The red in this case is the bottom one. So this blue on my calculator, red on my calculator. So they look pretty good. All right. So I'm going to do one more, and then I'm going to have you try one. So period, amplitude, phase shift, vertical shift. So in here, before I do my periods, I'm going to take out that pi over 4. So if I divide pi over 4 out, pi over 4 divided by pi over 4 is 1. And pi over 4 divided by pi over 4 is 1. So I could rewrite this equation as 3 sine pi over 4 x minus 1. That just makes it so that I've taken that pi over 4 out of my parentheses to make the period and the phase shift simpler later. So the period is 2 pi divided by pi over 4, which is 2 pi times 4 over pi, which would be 8. Amplitude is what's in front, so 3. Phase shift is what's added or subtracted in the parentheses after I divide out the period. So we're going to go right 1. And vertical shift is what's added or subtracted, so this one has none. So if I were to graph this one by hand, our period is 8, but our phase shift is 1. So let's see, pi is 3.14, so 1 is, so it's like 1.5, so 1's about here-ish. So that's usually your phase shifts kind of match the periods, like they'll either both be in terms of pi or they won't, but so we're going to estimate on this one. So let's see, 1 is about here. So we're going to go right 1. It's sine, so we start on the origin. So vertical shift. There's no vertical shift. So one thing that's helpful is some people will like draw the midline just so they know. That way if there's a vertical shift that's down 2, you know where your middle is. So no vertical shift, sine starts on the midline, right 1. And then I go a period of 8. So 2 pi, 6 times 2 is 12. So hold on, bring my calculator back for a second. 2 pi is 12, 2 pi is 6.28. So let's see. 8 divided by pi is 2.54 pi. So 2 pi, 3 pi, 3 pi over 2, 4 pi over 2. What's 5 pi over 2? 7.85. So let's say 8's about here. We're estimating the ones on the computer would give you units that are helpful. So it's about 8. So the middle is going to be about 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, about here. And then the amplitude is 3. So, and we're positive. So in between the first 2, we're going to go up 3. In between the second 2, we're going to go down 3. And then that would be a period. So if you were doing this on the computer, you'd put those 2. If you showed me this work in your notes, and then you had those 2 dots on your graph and the computer marked it as wrong, I would at least be able to see in your work that you did that and estimated, and I'd be able to give you credit. So that would be a reasonable thing to do if they didn't give you pretty units. So why don't you pause the video and try this one? All right. Period, amplitude, phase shift, vertical shift. So if we divide out, if we divide out the pi over 3, we get x minus 6/5 pi over 2. I don't know why that's writing on 2 pi's here. Okay, right, pi over 6 divided by is pi over 6 times 3 over pi. 1/2, yeah, okay. Had a moment. All right, so my period is going to be 2 pi divided by pi over 3, which is 2 pi times 3 over pi, which is 6. Amplitude is 2, but we're going to go down. Phase shift is right pi over 2. And there is no vertical shift, so my midline's right here. Phase shift right pi over 2 means I'm going to start at pi over 2, but my amplitude is 2 and it's cosine. So I start at my middle, or no, I start at my minimum. And then the period is 6, which is just under 2 pi, so it'd be about here. Which means the maximum's in the middle. 1, 2, 3, 4, 5, 6, 7, 8. So about here. So about here and about here. So it's going to look something like this. And again, you'd graph these two. But if you showed me your notes and the scales weren't good, I would give you credit. So that is section 8.1. It really is about finding these 4 things from the equation, putting them in the equation, and being able to plot the mins and maxes and midlines. Let me know if you have any questions, and we will go from there.